What's up guys, 8677116 here, and welcome to my 5th Redstone tutorial. Now in this tutorial, we are going to be looking at Redstone comparators. Now just before we get into this tutorial, I'd like to ask that if you enjoy this video, please leave a like, and if you'd like to support the channel, please subscribe, and I'll just tell you that the next video I'm going to make is going to be on observers, but for now, let's get right into Redstone comparators. Now, redstone comparators are one of your more complex redstone components that you can find. And this is going to be a bit tricky to swallow, but I'll show you the main uses to make it a bit easier for you to know. So, let's start over here. In comparison mode, with the torch down, so when the torch is down like this, it will compare signals and only output if the side signal is less or equal to the input. So if I put in a signal strength of 14 into this hopper as defined by this piece of redstone, and I put a signal strength in here, it will output the same signal strength. But if it's less, it will also output. However, if I have lever number 12 on, which is this one, and then I have lever 12 on here, you can see it's still the same, but once I increase to 13, it turns off. And it's the same with 14. So you see, if the side input is more than the main input, it won't turn on. But if it's less or equal, you will see that it does turn on. And it maintains the same strength until you get to this lever, where it will completely turn on. So it's either all the signal strength going in, or none of the signal strength going in. In subtract mode, with the torch up, it will subtract the side signal strength from the main signal strength. So to toggle the torch off, all you gotta do is right click it. So if I put in a signal strength of 15 and subtract 14, it will only put out a signal strength of 1. Same thing if I do a signal strength of about 2. And if I subtract the signal strength of 1 from it, it only has 1. So this allows for comparators to be used in a few different ways. So if I do 2 take 5, it has nothing coming out. And it has a few different uses. So you can subtract the signal from the side to the signal that's coming in. Now, the best use I know for this is here. In subtract mode, a comparator can work as a redstone valve. This is great for trap disarming circuits. So say you have this linked up to a pressure plate, and it also links up to a door. But then this signal links up to, say, a bunch of TNT. Now, with this lever off, you can see that the signal will transfer and the TNT will go off. But say if you have this lever toggled on, it will stop the signal completely. So you need a repeater, because you gotta always make sure this is stronger than that. And otherwise this won't work, and you just end up making a hole in your base. Now, hoppers and other container items react with comparators in different ways, because it can measure the item capacity of those blocks. So you see, this has 5 stacks. So it's giving a signal output of 15s, as shown right here. If I press F3, you can see that it's at 15 power. Now, this also works the same way with non-stackables. So if I put this sword in here, it still gives power to this redstone output here. And if I remove this, you can see that it's gone down by 3. So it's gone from 15 to 12. And this also works similarly for other items such as chests. Okay, say you have this chest of items. Now, with chests, it's a little bit trickier to find out their signal strength stuff than a hopper would be. But what you need to do is you need to find out how many slots the container you want to use is. So a dispenser has 9 slots, one chest has 27, and a large chest has 54. Now you need to divide that by 14. You divide it by 14 because it only takes one item to give the first signal strength, and after that it takes a ratio based on that number. So if you take the number 54, which is how many items you have, and divide it by 14, that gives you 3.85. So that means that roughly 3.85 stacks will give you the amount you need. So I have 3 stacks here, still on 1. But now I'm going to put most of this stack, save about that ought to do it. And that sees you have 2 and only 2 single string. Now if you up this to 6 and only leave about 5 out, that ought to give it a single string. 3, a bit more than that. Want to do the trick? Okay, that's only 7. I need 1 more stack. Will that do it? That should get to 3. And where's the threshold? It should be somewhere around here. But so for approximately every 4 stacks, slightly less. So 3, 6, 9, 12. So that should bring up to about 4. And then a few more should put it up another one. So roughly every 4 stacks, but it's not completely exact because there's a bit left over. So roughly 4 stacks for this large chest, as you can see. But that's how you can figure that out. All you have to do is take the number and divide it by... Take the number of slots in your container and divide it by 14 to find out how many stacks it takes approximately to fill it up. So that allows you to figure out this sort of stuff. Now, a comparator can be used to carry a signal strength. So say you have a certain signal strength that you want to convey somewhere. Now, since every single comparator takes a tick, it will take a little bit of time to get to where you need to go. But if you needed it done so, you can do it with this simple circuit. So what I have here is a subtractor which is set to give a signal strength of 3. And if you look here, you can see it only has 3 power. Now what that does is it feeds this comparator. Now comparators allow the signal strength to go through without it decreasing. So it's kind of like a repeater that doesn't completely amplify, only amplifies it to the level it was in. But you can use this to transfer it through a block. And so you can see here that the signal strength is still 3. The same with here, and also here, and here, and here, and here. And the result is that once it gets to here, it will send this power to this comparator, which will power these lamps. So that you can use that to feed it into a customized decoder or something, which I'll show you how to build later in the same tutorial. But there are a few other things that comparators can do. Like comparators can also measure things from other blocks. So this lectern, you can see it has a signal strength of 1. And then if I up it to a signal strength of my choice, you can see that if I go here, it has that signal strength. So if I go all the way up to 15, that gives a full power that Redstone can use. It also works with a item frame, which can give you up to a strength of 8. So every time you shoot it, it will go up 1 signal until you get to here, where it's up at 8. And then you flick it once more, it's back to 1. It's also the same with a composter. With this pumpkin pie, if I up it, it gives a signal strength of 1, then 2, then 3, then 4, then 5, then 6, and then 7. And then once it's fertilized, it gives a signal strength of 8. Okay, so this cauldron can give up to a signal strength of 3. So if I fill this up, it's a signal strength of 3. And then if I empty it, it goes back to 2, then 1, then 0. So that's how you can use a cauldron. Now a bee's nest also can give a signal strength up to 5, depending on the honey level. So this honey, you can see this beehive has a honey level of 5. So it's going to give a signal strength of 5, as you can see there. Now if I empty this beehive, there's no bees here. Yeah, I just put that hive there without any bees. It's gone back to 0. So you can use this technique to build honey farms, which I'll show you how to build very soon. Now just to show you, to craft a redstone comparator, what you need is 3 stone, 1 nether quartz, and 3 torches like that. And that's how you get a redstone comparator. Okay, so that's everything I've got to show you in my comparator video. Now we'll go into my machine tutorial as well, where we'll build a honey farm and a few other things. Alright, so you can see I've got this little setup with flowers and 3 bees and a beehive. Now, you can build a honey farm out of a beehive by harnessing the comparator output of the honey level. So if the honey level gets up to 5, that means it can be harvested. So what you need to do is bring a redstone signal out 5 blocks. Then at the very end, you need to place a redstone torch. This will then run down a redstone signal along here, which will power a dispenser with bottles in it. Now, if a dispenser has bottles, it will harvest the honey from the hive. But if it has shears inside of it, it will harvest the honeycombs. So what this will do is, okay, actually this is meant to be a block, and this is meant to be a torch. So now this is set up. All you need are some bottles and some shears, depending on what you need. And then I'll just set this up with a few bottles and some shears. And now what it's gonna do is, as the honey level of this beehive increases, it's gonna build up here, and then once it gets to 5, it will turn this off, which will turn this on, which will harvest either honey or some honey or some honeycomb. So I'll just let this sit for a little bit, and we'll come back to it. Okay, the bees have done a little bit of work, as you can see, so now the honey level is up to 3, which means this should be up to 3 levels. So this means that they're working, and okay, now they're pollinating these flowers I've got set up, but in a little bit of time, they'll go back into the hive and start doing more work, and in a couple of seconds or a minute or so, we should get some honey or honeycombs. Actually, I'll just make sure it's honey by overriding it by just using bottles instead of shears. And then the items will end up in here. I'm going to show you how to make a hopper sorting system in a later video, but after this I want to show you that decoder I was telling you about. A watched hive never gives honey, or so they say, but we'll see what happens. Oh, is that it? No, not quite. Oh, there we go! That's it! Got a bottle of honey. So now you can just leave this going. I'll do the same thing, but now with some shears, and that will give some honeycombs. We're up at a signal strength of 3, and shouldn't be too much longer before the bees leave, and I get a few honeycombs from these shears. Hope it was shears, otherwise I'll be a little bit annoyed, but pretty sure it was. So just keep waiting, waiting. If I didn't get rid of that thing of honey from my inventory, I could drink it. But since I'm in creative mode, I may as well. Now, this is a recipe for disaster. A recipe for type 2 diabetic disasters. Pillagers have come for my honey! That's it. Kill at E type equals pillager. Alright, let's see. Shouldn't be much long. Oh, this must be it. Very close. Okay, just gotta wait a little longer, and let's hope that it will get to that last single strength. Oh, there we go! And now it's... It didn't get put into the dispenser, so is that a bug or a feature? I guess you have to use a hopper collection system, but well, I've just shown you the basics for beehive farm, and now I'm going to show you how to build a redstone decoder. Alright, I have a lectern here with 15 pages, and if I go to any of the pages, the signal strength will be exactly that which is stated on the page. Now, say you want this machine to do something special for every single page. Say this is like an order log for some sort of shopping system, and then like when it's that shopping system, you press a button and then you get that item, and something like that. Well, what you need to do is an item decoder which will have a signal for every single different page. So what you need to do to build this is put a block here, then place 15 pieces of redstone here, There we go, that's 15. Then, now you need to put some blocks off to the side, like this, and also put redstone on it. Then you need to place some blocks around here, and put redstone on top of these as well. Now after this, you need some of these, and place them here. And now that you've got that done, you need to place redstone torches along the side of all these. And then you need to place some repeaters on top of every single one of these on the same tick. Then you need to place a block off to the end. And then your output torches are going to go here. So this is going to be the output. So for every single different page, it will go to a different torch. So if we go back to page 1, you can see that torch and only that torch. It'll lit the same with page 2, 3, 4, 8. You can see that, the 8th torch is lit. And then you can keep going from there and have 15 torches. Now, there are 2 ways you can power off from here. You can do some redstone signals off to the sides and a couple on top of the torches, so every signal can toggle a different thing. Or you can use a bunch of repeaters along the sides. So, as you can see here, I can put these redstone stuff around here, and I could probably power a lamp, and it can even show whatever stuff you can do. So this is going to be useful in some certain circumstances, like when you want to decode stuff, and it will be quite useful when skulk sensors come out in the next update, which is gonna, because when you use them, you can use one of these to tell how far away the player is, or if you're using comparator on the skulk sensor, you're going to be able to tell what sounds are being made. So now you can see that I have number 15 on, and then I can change it back to say number 8, which if you go over here, you can see the 8th is done. So that there is how you build a decoder. I've come back to the drop trap design I built in the 3rd tutorial, so I want to build it in a way where I can toggle the trap on and off. So say if I want to use this door, I can walk right in without dying, but then I can flick a lever which will set it in trap mode, so someone will walk through this lever, it will activate the trap. I'll just set that back to about 3. So how would I do that? Well, with comparators, it's easy. All you really got to do is find a place for your comparator and find a way to be able to power it from another source. So I'll just put a repeater here, and then that can be powered from above here, and then this can run into some other block. Well, actually, I will need that in subtract mode. So say if I run it into here, then I should be able to place a lever here, and that should be able to turn that on. So what this should mean is I should be able to walk through with nothing happening. But if that lever is off, and I walk through, I get a bath in a certain liquid known as lava. So if I come back out of here, you can see that the design was a success. So with it off, that will trigger the trap, and then with that on, it will disable anything from going through that hopper using this valve, and I can walk through here without fear of trapping. And with it off, yeah, that happens. So that is by far my most common use for a comparator. I like to use it as a disabling system, and this is a very important circuit. You can have one piece of redstone between it, or a piece of redstone and a block. But if you have anything more than that, like say another piece of redstone, the signal strength will go down a bit, and it's generally best to keep the valves to have a strength of 15. It's the best way to make them reliable. So generally it's a good idea to keep the repeater, and that's just certain this will be a signal strength of 15. Anyway, this is going to be the end of this tutorial. I hope you enjoyed it. If you did enjoy it, please leave a like. If you'd like to support the channel, please subscribe to it. And I'll expect over the next coming weeks I'll make a video on observers, so that will be the next video I do on Redstone series, and stay tuned.